Hi everyone, I'm thrilled to be here today and to have this opportunity to talk about OpenTelemetry for platform engineers and how you can pave the road for self-service observability. I spent 8 years myself as a platform engineer, or SRE, DevOps, whatever we called it through the times, at a Nordic challenger bank. So I've also been in the trenches trying to do all the different things. But now I'm working as a principal developer advocate at Zero. And basically, I just love to be involved in this community. I've been doing all kinds of different things, meetups, co-chairing this event as well, CNCF ambassador, but yeah, enough about me. So I want to start out by talking a little bit about how the current situation is in observability in many organizations. And I think AI did a really good job on this. So for many years, we've talked about like the 3 pillars of observability, or the 3 browser tabs of observability, if you like. But in reality, there's a lot more browser tabs or pillars than that, because you probably have like real user monitoring, like web applications. Maybe you have mobile. Maybe you have some profiling. You run pprof on some of your services. So we have more than just the 3 pillars of observability. So let's stop talking about that. And also with this growing amount of services out there, microservices are just like exploding everywhere. Maybe hundreds, thousands even. So when things go wrong, it's really, really hard to find that specific needle in a haystack that you need to fix. And each of these browser tabs or tools provide like a partial incompatible view of what is actually going on. So you probably need more than all of them to get the full picture of what is actually going on. And this fragmentation, or you can also say lack of coherence, leads to many challenges. Or one of them being that we have each of these tabs might have their own query language or their own filtering way, their own UI. There's tons of different ways and to get the data that you're interested in. And you need to be an expert maybe in all of these, which like takes a lot of cognitive load for everyone, especially in a situation during like 3 a.m. in the night. You don't want that hurdle. Also, when you are selecting this, there's most likely some kind of agent you need to run. There might be a library or framework. So there's login, which creates barriers for you to switch tools, which is also quite bad. There's a metadata inconsistency because your naming is hard. So we might call something in one system, something in a different system. And then when you need to actually correlate, you do that manually, like human correlation. And that is just hard to do. And then because of all of this complexity, we probably, on many teams, don't instrument all together. So we are missing the lack of, we don't get the lack of insights or the unified insights, and troubleshooting just remains slow and inefficient. And it really forces you as an engineer to manually piece together this information across all of these different tabs or systems, if you like. And to take this a step further, because you as a platform engineer, you kind of wear 2 hats. You are responsible for observing the platform. You have your cloud, your clusters, your shared databases, whatever you have. But you also need to enable the developers to also, for them to take on the responsibility of monitoring and observing their applications. So you probably need to provide some kind of auto-instrumentation. You need to provide us like a solution for logs, metrics, and traces, real user monitoring, et cetera. You can say that the first hat kind of protects global reliability, whereas the second amplifies developer velocity. And just to top it off a little bit more, observing the platform also includes that you as a platform engineer provide some kind of metadata or context around the things that you are delivering. So you probably need to tell like the ones that are running on your platform that this is on this host, it's this pod, and all of this information needs to be propagated up the stack to the developer so they actually know where things are going wrong. And to top it even further, we have this thing. There's so much stuff out there. This is only the observability, it's called observability and analysis. So there's so many different tools out there. But luckily, I think there's one project on this slide that is sort of the foundation for many of the others, which is OpenTelemetry, which is up there. Because OpenTelemetry can be used with a lot of these tools, and we'll come back to that later. So let's talk about observing the platform, because the foundation here is OpenTelemetry. At least that's what I think. It's a really cool project that aims to build the foundation of how modern systems are observed. How many of you are familiar with OpenTelemetry? Good. How many are using it today? Oh, quite a lot. That's good to hear. It's a lot of different things. It's like a data model. It's API specifications. It has semantic conventions, so they actually agree on what things are and what it's called. It also comes with SDKs for different languages. And it comes with utilities like the OpenTelemetry Collector, the operator, and I'll demo that in a second, and hopefully that goes well, but we'll see. What it's not is it's not proprietary. It's not like an all-in-one solution. It's not a storage backend. It's not a query language. So there's a lot of things it's not. It's really focusing around how we are collecting telemetry and standardizing that. This is from the velocity report from the CNCF last year. It's actually the second largest project within the CNCF by contributor count. And last year it had more PRs plus issues than Kubernetes itself. So it's a really project that's up there, and there's a lot of things going on in this. I think there's around 90 projects within the OpenTelemetry project itself right now. So it's a huge project, and it does a lot of things. It can collect all of these signals. So we have metrics, we have logs, we have traces, more like in stable versions, whereas real user monitoring and profiling is still like experimental features. So you can do a lot of things already with this project. And as I mentioned earlier, let's stop talking about these three pillars of observability, because maybe they never even existed. And I think Charity Medias just a couple of weeks ago put out this blog post. I think the title is, how many pillars of observability can you put on a head pin? And then it also links to this pretty cool page that I wasn't aware about, that there's actually a website that has a manifesto that tries to kill the three pillars. So if you are interested, you can sign a manifesto and try to help kill the three pillars of observability. And also because we don't have metrics problems or tracing problems, we actually have systems problems, right? And there's something wrong with our systems, and we need the different signals to tell us what it actually is the issue. And the cool thing about OpenTelemetry is that it provides correlation as this kind of superpower to the project. So if you're running the collector, you can collect all of these signals, and you can start to correlate, because we are collecting all the different contexts and the resources we are running, and that it makes us able to correlate the different signals. And that's really where I think this project comes into play and is like the foundation of how we are building things. The cool thing, yeah, this is the slide. The thing you need to do and run most likely to do all of this is the OpenTelemetry Collector. And what you do is you instrument your applications. You either auto-instrument that with one of the agents or whatever that it's out there, or you use the SDK, and then you can also monitor and observe your infrastructure. But you use the collector to receive, to process, and export your data to some telemetry backend, whatever that backend might be. It can be all kinds of different things. So OpenTelemetry really focuses around how to collect all of this telemetry, and you can export it to somewhere else. It could be like vendor-based, but it could also just be to Prometheus or Jaeger or OpenSearch or whatever you'd like. That's really up to you. But it allows you to send the data, or route the data to multiple different backends, which is quite nice. It gives you freedom as an end user to choose, and basically pushes the vendors to fight on a different level and basically provide the best possible experience with your data, which is quite cool. So now that we know that OpenTelemetry is really the foundation, then how can you as a platform engineer make it available to your developers? And I think observability as a product, I think we talked a lot about platform as a product. We should also talk about observability should be one of those products of the platform. Because, as you know, it's not feasible for everyone to, master clouds and clusters and security, and it's the same for observability. We need like a specific team or platform organization to take care of that. So we should treat it as a product. And for developers that are like coding away, they're in flow, they're doing their thing, I think that observability should kind of feel invisible to them, but it should never be absent. And what I mean by that is that if it's like this kind of a safety net that they have, that if something goes wrong, they know exactly where to go and where to fix it and get all the information. Because observability, when something goes wrong and you are like providing this as a service and you've thought about this, you've done all of the hard work, then it becomes like this high contrast lanes that basically just tells you that this is what is wrong, this is how you can get back to a good state. The goal about treating observability as a product is not to turn every developer into like a telemetry expert. It's to make good telemetry show up by default. So when something really breaks, it already all the evidence is really there. And basically, if your team follows the paved path, they get all the signals, they get all the information they need out of the box. That's really the vision. I think many of you probably know this. A digital platform is the foundation of self-service APIs, tools, services, knowledge, and support managed as a compelling internal project. I really love this quote by Evan Butcher. It's on the Martin Fowler blog. The goal of treating observability as a product is really, again, same like arguments as platform as a product. It's really to have developers focus on them spending time delivering some kind of business value instead of like fighting different observability solutions or trying to build a pipeline or whatever it might be. And platform engineers, observability engineers spend their time on building like the product that makes that available within the organization. So observability fits very good in here. It's not a side system. It's not something you just buy and implement. You really need to treat it as a product and think about it as a whole so that it becomes this feature or capability of the platform product that every service consumes. I usually when talking about platform engineering, I usually bring these just to level set a little bit. I know, Paula, you use them also. But what it's all about is it's about providing this self-service experience. Also for observability, it should just be there by default. It's having like explicit and consistent APIs. It's building golden paths, but it still allow for some kind of modularity. And you can do that using the OpenTelemetry Collector. There's multiple ways to do that. And then, of course, platform as a product, meaning, again, you provide the support, you provide the proper documentation. Maybe you even have like the internal advocacy going on, depending on the size of your organization. And then the core requirements or the defaults, same defaults, is really about building in, for example, in the collector, you're redacting user emails or social security numbers or whatever it is, or removing debug logs from production. There's all kinds of ways that you can build this in to be a really good product that sort of fits your organization. One way to come to a point where where your developers can then just deploy their applications and they will get a good default is by using the OpenTelemetry operator. And what you do is that you run the operator, and I'll show you that in a second. It has this CRD called an instrumentation that basically allows you to add an annotation to a pod spec in any of these languages. Looks like this. Either you inject Go, Java, .NET, Node.js, or Python, and then it will take care of auto-injecting the auto-instrumentation for you so that you don't have to do anything. You can either say true or you can point to a specific resource up here. That depends on how you're configuring this. So I think I have plenty of time to my demo. That's great. Before going into the demo, I have a few sort of visuals that show you what the demo will look like. So we will have a front-end application. It's written in React. The goal here is just a simple to-do application where you can add like a to-do. I need to do this thing. It talks to a backend that then persists its data in a MySQL database. Then it uses RabbitMQ because I needed to, extend the demo a little bit and make it a little bit more fun and challenging. So I wanted some async communication as well. Let's say that we wanted to send an email when someone created a to-do or whatever. So that's a notification service as well that receives, whenever a to-do is created, it receives or publishes a message on an event on RabbitMQ, and the notification service then consumes it. And then the front end, just to visualize everything, there's an API in the notification service that basically can show you that it actually received the message. And now we are tasked with actually implementing a new service. So imagine that these services are maybe owned by a few teams, and now we are a new team that comes in, and we want to build a new service that basically goes out and validates whatever to-do is created. It cannot contain any bad words. And yeah, we basically have the service that needs to basically give a thumbs up or thumbs down, and that's basically what we'll try to do. And then I'll show you how all the auto-instrumentation and all the things that are working is part of this. We will use the OpenTelemetry Collector. the operator. And the collector is configured in this way because we have a deployment. This is deployed through the Helm chart. The collector is basically, we have a deployment which is more like a cluster level collector that collects all the different data or telemetry from the Kubernetes API. It talks to RabbitMQ, gets metrics from there as well. And then a daemon set that runs on all the different nodes in the cluster that talks to the kubelet. It gets information. It picks up logs from via the file log receiver. It does a lot of things. So that's more focused on the nodes rather than the more central parts. Oh, sorry. So let's quickly jump into the demo. I just need to find my window. There we go. Mirror. Perfect. So I have a cluster here locally on my machine. Is this big enough? Yeah, I think everybody can see. So we have the OpenTelemetry operator running here. We have a few agents. We have the front-end application. We have the to-do backend service. And then we have the notification service. I'll be using an observability stack comprised of Jaeger, Prometheus, and OpenSearch for this. It's not really covering the correlation part, but to keep this very open, I will be using these tools. You could, of course, send this data to anywhere you'd like and see the correlation happening if you are using another tool for that. Yes, so let's jump into it. You can also see all of this is, there's a QR code at the end, so if you want to try this out yourself, you can do that. But the front end looks like this. It's a simple website, and let's just say buy an hotel T-shirt or something. And you can see we created the to-do, and then this is the response from the notification service, so that we can actually see that the event was sent over the RabbitMQ setup. So what I want to show you now is that we have Jaeger running. And let's just find the traces. I can find the specific one. And you can see that we have this full trace from the front end to the back end to the notification service. You can even see in publish. You can see that notification service down here, it's consuming. Let me just see if I can find that. So this is the producer. Yeah, so you can see the full trace of what is going on. But now we need to implement this validation service so that we can have that be part of the trace. We can see that it just automatically goes in and be part of the full trace. And to replicate sort of the setup in an organization, maybe you might have Backstage running. I cheated a little bit because my template for Backstage here is the actual service. In reality, you would probably have like a Node.js template or whatever with some defaults. This is the actual service. It already pre-filled everything for me, so it's just for demo purpose. But it hopefully showcases that this is the experience that a developer would sort of get when they are doing this. So we see that the service was created. I get some information. My platform engineers was kind enough to provide me some next steps. This is what you should do now. So I'm just running Docker build. This one is maybe only for demo purpose, but I'm loading the image into kind. You would probably have like a CI/CD pipeline or something here to actually do this. And then we can apply the manifest. And let me just quickly do that. Great. So just to show you that this was actually created during this demo, you can, this one. There we go. You can see that this was created right now. And what you can also see is that we get all of these files by default. It's a Node.js application, as I mentioned before. We can also go in, if I can hit the right buttons, and look at the actual code. We can see that this is the Node application of the validation service itself. There's no specific instrumentation here. There's nothing about OpenTelemetry or anything like that. It's just a Node service that basically just checks for bad words. And a bad word is bad, terrible, and awful. That's basically how it works. It's very simple. And then it also returns 400, which is, I guess, not the way you would handle this in a real situation. But this is for demo purpose. And if we just quickly take a look at the deployment, we can see that our platform engineers also took care of adding this annotation for us. So I, as a developer, don't have to do that. That is just a default of the platform. Great. Let's see if everything is running. So the validation service is now running. That's perfect. I need to enable a feature flag because the to-do service team, then they wanted to do this at their own time, so they just like wrapped everything in a feature flag, and then they can just enable it when the validation service is ready, and it's ready now, so let's just enable that. So let me just quickly check everything is running. Perfect. So if we go back now to the demo front-end application, and I write awful, let's just do that. We can see that the validation failed, which was expected. We can also just say, I don't know, valid, just to make it simple, because I see I have 5 minutes left. And that was created. So that's perfect. So the actual service works and does what it's supposed to do. So if we go back into Jaeger now, and let me just find this, you can see that it's actually part of the full trace. It's right here. So this was the successful one. So you can see that it just became part of the full distributed trace, which is what you wanted to happen. So if someone goes into this call chain or whatever, then it just becomes part of this. And no specific instrumentation was added to the code to do this. This was all handled by the platform that just basically took care of this. And a lot of abstractions, of course, with Backstage. And basically, that's how we can do it. You can also see the one from before. That was an error because I received a 400 from the validation service. So yeah, that's pretty cool. Then of course, yeah, we get all kinds of information as well. So we can search for Node.js. So you can see that it's already picking up information from Node. We have RabbitMQ. We have all the information available to us. All of this is just taken care of by the platform. But one thing I also want to quickly show is that, and I didn't mention this on the slide, another thing that you could put in as a platform team could also be like default dashboards. It could be alerting. It could be SLOs. It could be all kinds of different things that you probably want to have be part of the ownership of a service. So for this demo, the platform team, which was me, I guess, added also a dashboard. So you can see there's a directory called dashboards, and I should just do bat here instead. And they created a Perseus dashboard in this case. Whether this is how you want to do it or you want to centralize all this, that's a different way of doing it. There's many opinions on how to do this, but this is one way you could provide like dashboarding as part of the platform product or observability as a platform product. And what this does, it's basically just defining some panels. Perseus is another CNCF project. It's a sandbox project that basically aims to provide a specification for dashboarding. And I hope more vendors will adopt this. We are using this at Dash0. I think Chronosphere is doing the same. But what you can do then is just quickly applying this, because I'm running out of time. Dashboard, validation, apply. I have Perseus running, I have the operator running, so I can just apply this CRD. And if I go into Perseus now, which is this platform, I can see that I got some metrics. So that's pretty cool. I got that out of the box from the platform team as well. So you can build in a lot of different things that are part of this platform product. So this is what you saw. You can send, in this demo, I'm also sending to Dash0, but that doesn't matter. But I'm sending all the different data to the different backends. You can build your defaults, how you're adding this annotation. That's really up to you. You're probably using many different tools out there, but Backstage was what I was using. You probably want Argo CD or Flux to do like the GitOps and everything. You could probably build something into a Helm chart. There's many different ways of doing this. So observability is evolving quite fast these days, and I think OpenTelemetry is really the project that are standardizing telemetry collection. And by applying platform engineering principle, it can transform observability from this afterthought into a seamless, scalable, and developer-friendly experience. And remember that observability is a systems problem, not a logging or tracing or metrics problem. And when we connect signals together, we empower developers to solve problems faster. And if you think this was interesting, like observability for platform engineering, my colleague and I did this course on platformengineering.org. It's free. You can just sign up. I have a few stickers here as well. There's also this white paper that just came out the other day, which is basically highlighting all of these different things. I have an OpenTelemetry book for dummies if you're interested. I have a few copies down here if anyone wants it. I have 6 copies here. And with that is all I have.